All right, next example. We're given that GO and LF are parallel, OL and GF are parallel, and our job is to prove that G and L are congruent angles. So the sub-step, or the step kind of before proving this is true, is we'll want to prove that the two triangles are congruent. So we're going to start by proving the triangles are congruent, and then we can use the CP-CTC, like we've seen before, to prove that angle G and angle L are congruent. So first off, let's kind of figure out what we have here. These segments are parallel, GO and LF, and that refers to GO and LF. Well, what of it? Well, with parallel lines, you should always be thinking about angles. And in particular, well, which pair of angles? Those yellow lines are parallel, and they are cut by this transversal, OF. So if we've got parallel lines here, cut by a transversal, we're thinking about angles. And in particular, the only angles that touch those yellow lines are angles 1 and 4. So GO parallel to LF, that gives us angle 1 congruent to angle 4. Next piece of given information is that OL is parallel to GF. OL refers to this segment, GF refers to this segment, and they're still cut by that red transversal. However, the angles that are congruent because of that fact are different. Angle 2 is created by a green line. Angle 3 is created by a green line. And so that means that angles 2 and 3 are congruent because OL is parallel to GF. So we've got two pairs of angles. The way that this particular image is drawn, we've got a shared segment, OL. And since we have two pairs of angles, we can either use AAS or ASA. Oh, ASA. But which one is right for us? Well, we've got to think about the included side. If you just consider triangle GOF, I'll just recreate it down here, GOF. So that's this triangle in here. Oh. That triangle. So if we just look at that triangle, we've got angle 1 up top here. We've got angle 3 down below here. And then we have that shared segment right in the middle. And so this follows angle, side, included side, angle. So we must use the ASA theorem and can't use AAS. So let's get to it. Let's write the proof. All right, so earlier we talked about using the two triangles congruent as a sub-step along the way. So we want to use the fact that GOF and LFO are congruent first. And however, the proof itself, remember, asked us to prove that angles G and L are congruent. And so once we've established that the two triangles themselves are congruent, we can use the CP-CTC to say that angles G and L are congruent. All right, so now let's get back to the bulk of the proof up above. We need to talk about a pair of angles, a pair of sides, and another pair of angles. From the given information, we know GO and LF are parallel, which meant angles 1 and 4 were congruent. Similarly, because OL is parallel to GF, angles 2 and angle 3 are congruent. And then lastly, OF is a shared segment in both triangles, and as a result, it'd be congruent in both GOF and LFO. So now our proof is done. Scroll through it so you can take a look at the final proof. It kind of looks like a 6, doesn't it? It should be a G.